Welcome to Pass Academy. In this video, we are going to look at cycloalkanes. So cycloalkanes are named by using the prefix cyclo and then the alkane name to indicate they are cycloalkanes. So let's look at the molecular formula of cycloalkanes. The molecular formula of cycloalkanes is given by CnH2n. So if you have a cycloalkane with, let's say, 3 carbon atoms, then how many hydrogen atoms do we need to attach to this? So we have 2 times 3, which gives us C3H6 as the molecular formula of our cycloalkane. So let's look at how this cycloalkane looks like structurally. So we have this as our cycloalkane, and then it is bonded to hydrogen atom here, another hydrogen atom, a hydrogen atom here, another one here, another here, and another hydrogen atom here. So we can see in all we have 6 hydrogen atoms being bonded to the carbons in our cycle. So let's move on to the naming of cycloalkanes. So if we have a cycloalkane in this way, we count the number of carbon atoms in the cycle. In this case, we have 1, 2, 3, and the name of an alkane with 3 carbon atoms is known as propane. And the rule says we add cyclo, the keyword cyclo, to the alkane name to indicate it is a cycloalkane. So in this case, we add cyclopropane to indicate our propane is a cyclic alkane. Likewise, you can have different cyclic alkanes. So we have this one having 1, 2, 3, 4, 5 carbon atoms, and an alkane with 5 carbon atoms is known as pentane. And so we add the keyword cyclo, the name of the alkane, to indicate it is a cyclic alkane. You can also have cyclic alkanes or cycloalkanes having substituents on their cycles. So we can have example this. So we have a substituent being bonded to the chain, the cycle here. So we indicate our substituents. In this case, we have methyl. And so in naming this cyclic alkane, we count the number of carbon atoms that made up the cycle. So we have 1, 2, 3, 4, 5. So we have 5 carbon atoms in a cycle. Therefore, our cycloalkane is given the name methyl cyclopentane. As pentane indicates we have 5 carbon atoms, and then cyclo indicates it is a cyclic, and then methyl indicates the substituents. We can also have 4 substituents forming on our cycloalkane. So example, we can have this as our cycloalkane being bonded to substituents like bromine here. We can also have another substituent here. We can also have here. So the rule from the IUPAC rules, we say we give emphasis to the alkyl groups. So in this case, we can see a halogen here, and then we can see alkyl groups here. So we give emphasis to the alkyl groups. So let's assign number 1 here, number 2 here, 3, 4, 5, 6. So we have 6 carbon atoms here. Let's try and then number the other way around. So we have 1 here, 2 here, 3 here, 4 here, 5 here, 6 here. So we have to give emphasis to the alkyl groups, and so the alkyl groups, in going this way, we have 1 here, 2 here, and so we take the least possible numbers given to the alkyl groups. And so the name of this particular cycloalkane will be the cyclo. We have 6 carbon atoms, and so we have hexane. And then for the substituents, we have methyl bonded here, and then we have another methyl here, and so we have 1 and then 2 dimethyl, and then we have bromo here, and so the position of our bromo is 4. And then we assemble these names alphabetically, and so in alphabetical order, we have 4 bromo, 1, 2 methyl, and then cyclohexane, indicating the cyclo here, indicating our hexane is a cyclic alkane. We can also have cycloalkanes forming substituents. So we have a straight chain in this form. So we have something like this, and then we have, so this is our cycloalkane forming a substituent on this particular straight chain. So the rule says we should identify our longest straight chain. So this 1, 2, 3, 4, 5, 6, 7, 8. So this indicates our longest straight chain, and an alkane with 8 common atoms is known as octane. Then we assign locations to the substituents. And so we give the least possible number to the substituents at the closest to the end of the longest chain. And so when we start counting from here, we have 1, 2, 3, 4. And then if we should start counting from here, we have 1, 2, 3. So it is 4, 4 either way. So we have 4 methyl, and then we have 6 cyclopropyl. So this cyclopropyl indicates our propyl group here is a cyclic propyl or cyclic alkyl molecule. So in naming this particular alkane, we have 4, we have 6 cyclopropyl, and then 4 methyl, and then the name of the longest chain giving us octane. So the name of this particular alkane It says cyclopropyl 4-methyl. This brings us to the end of this lesson. Meet us in the next video for more educative videos.